next up we have Fermata Energy, and they're going to do a tandem approach with us. Excuse, I'm sorry. And leading off is Facundo Tesara. Facundo, go ahead. I'll let you take the stage.
Hey, thanks. We're really excited to participate today, and really excited about the event coming up in October. So we're going to go through a lot of new information here. So please feel free to contact us, email us, call us anytime. We're willing to help and answer any questions that you might have. So who is Fermata? Well, Fermata supplies and operates vehicle-to-grid technology that integrates with EVs and building electrical loads in the electricity grid. What's critical to know here, though, is that as I'm talking to a lot of my colleagues, my previous fleet colleagues, I should say, when I was a fleet manager, and I talked to them about what vehicle-to-grid technology is. There's an understanding that what it is, it's taking stored energy and selling it back to the grid. And while that's partially true, there's a lot more opportunity that vehicle-to-grid offers, and that's what Fermata does. We really make all of those opportunities available to you. With V2G systems, EV batteries. John, are you on the call? Can you move to the next slide?
Oh, here, I'll move to the next slide.
Okay, thanks. EV batteries are not only valuable to the grid operators and to utilities, we'll talk about that a little bit later on, but they're really valuable to the fleet operators and to the owners of the buildings, a lot of times facility maintenance departments. We're partnering with commercial and government fleets to help reduce their cost of operations, reducing their electricity loads, and then also reducing the total cost of ownership of their EVs and their charging infrastructure. What's interesting about government fleets is the duty cycles in terms of when they're parked. A lot of those vehicles, I should say when they're operated, those vehicles are driven, say, between 8 to 5 or 9 to 4, somewhere in that area. And so we build that into our business model, and we take into account their duty cycle, but that meshes well with V2G services. So what's the value of V2G for fleets? Well, there are several of them. I'm just going to talk about a couple of them. You're going to realize significant savings and a cost and return on your investment. Cost savings on your electricity loads. But what's interesting also to point out is right now, Fermata is doing a free electrical load analysis for anybody that wants to know and evaluate vehicle-to-grid opportunities. To see how much money you could save and how much money you can generate. For me, putting on my fleet manager hat on, my favorite part of vehicle-to-grid technology is that we aim to really maximize the utilization of electric vehicles. And so what do I mean by that? Electric vehicles, or really any vehicles in your operation, you set a utilization standard, whether that's, 3,500 miles or a certain frequency. What we all have, and those are all different from organization to organization, but what every fleet manager has in common is I kind of chuckle to myself when I ask fleet managers, well, what do you do with your vehicles when they're parked? And the answer is always, well, nothing. They're parked. And that's exactly what Fermata aims to do. We redefine utilization because we're bringing tremendous value when that vehicle is just sitting in your parking lot, and arguably more value sitting in your parking lot than being driven. So next slide, please. So what do you need for a vehicle-to-grid? Well, with Fermata's vehicle-to-grid technology, you require three things. You need an EV that's suitable for V2G operation. You need a bidirectional DC fast charger. Our current charger that's in development should be done by the end of the year or Q1 next year. That cost after installation is in line with many other similar DC fast chargers. The difference with our charger, of course, is that it's bidirectional. Other DC fast chargers, or maybe chargers actually, it's just a potential cost center where you're just always paying for your vehicles to get charged. In our case, with the vehicle-to-grid services, you're actually helping pay for that charger and hopefully even pay for the electric vehicle. And the third thing that you need is you need a software system that basically helps everything communicate. The EVs, the chargers, the grid, and other energy assets you might have, like such as solar and wind. And what's interesting about our software is it's a learning software, and it can anticipate demand charges. And what's really neat is that if you have an automated motor pool in a centralized location, for example, our software is going to be able to communicate to your motor pool, making the building a user of the vehicle, of course, to help reduce certain electrical loads through demand charge management. But what's most important to keep in mind here is that you, at the end of the day, the fleet manager, is the owner of the vehicle. And so you're going to decide whether the vehicle is going to be driven or whether you want it to be engaged in grid services. What Fermata is going to do is we're going to give you the information that you need to make that decision. As Rick mentioned at the beginning of the presentation, data-driven decisions. And I know that from being a fleet manager for several years. That's what it's all about. Lastly, the Fermata software is going to be continuously analyzing and execute optimal V2G opportunities given your vehicle's availability. That's key. That's what everybody needs to understand is your vehicle to be driven first. If you want to engage in grid services with the information we provide you, great, but that's your decision. Next slide, please. So what I didn't know about my electrical bills when I was a fleet manager was that a third of my electrical bills were composed of demand charges, and sometimes those demand charges are significant. I've seen bills, not necessarily my old organization, but I've seen electrical bills for industrial buildings and commercial buildings be $50,000 or $100,000. So just think about a third of that. That can add up pretty quickly. And so the demand charges, they occur in 30-minute intervals once a month or once a year. And so what's the potential economic value to a fleet or to an organization? Well, for each bidirectional charger, for each V2G system, you can save potentially $2,500 to $10,000 a year per charger. And so, you are really, redefining utilization and really getting some money back on some of the operation of your assets. And so you move to frequency, the revenue generation portion of it. Something called frequency regulation can help you bring in anywhere from $1,500 to $3,500 a year. And when you think about that, a lot of fleets engage in insourcing opportunities where you're repairing other fleets, other vehicles from other fleets. What's interesting about frequency regulation as well is that the vehicle's going to be writing you a check every month. And so, there's no staff time required in frequency regulation. When the vehicle's plugged in, it can be doing frequency regulation 24 hours a day or whenever it's plugged in. And that's an in-source opportunity for you that you're bringing money in. And there's, our software and Fermata Energy is going to be doing that legwork for you. And, of course, there's operational value as well. There's a disaster resiliency component. There's a battery backup power component to an electric vehicle. Think of it as a swappable battery. If you lose power in a certain part of town, you can basically drive your vehicle to a location and plug it in to a building. You need a few vehicles for that, but, you can do that. And something that we're working on as a future application is mobile backup power, driving to an intersection, plugging it in, running wastewater pumps, other, things of that nature. A good example of all these storms that are occurring, fleets are deploying all of their assets, whether they're generators or whatever whatever it is, they're out in locations that they usually service. But what happens when one of those goes down, or what happens when other things go down that you weren't expecting? Now you've got an EV that when it's parked that can, generate some significant value for you, and it can also be potentially a mobile generator. So that's a future application we're working on. Next slide, please. So John Wheeler's on the call with us from Fermata. He's going to talk briefly about one of our projects that we have going on. And he's also going to talk about some sample data of what demand charge management might look like for folks that are interested. John?
John, do you want to take control of the screen from here?
That's okay. Let's we can just keep going.
Okay.
If you could, yeah, this is fine. If you could just cycle through the next couple of pictures. This is our first commercial demonstration project, which we started about 2 or 3 years ago with the city of Danville, Virginia, which is a couple hours south of Charlottesville, Virginia, where our company is based. If you could go to the next slides, just kind of cycle through these. Yeah. We've got 4 Nissan Leafs that are 3 of them are being driven by the city of Danville, the real estate department, waterworks department, and IT department. And the 3rd Nissan Leaf is being driven by Severn Trent, which is a contractor that runs city infrastructure. Maybe some of you guys are familiar with them or potentially clients. Next slide, please. So two of the chargers are located at a wastewater facility. Another charger, this one, is located at a courthouse, and then the third one is located, or the fourth one is located at the city hall. What these vehicles are doing is doing frequency regulation at night, basically when the vehicles are not being driven, and they've been commercially operating in the PJM, which is the kind of mid-Atlantic region of the grid, since last November. So we are fully commercially operating. These cars are writing checks for us ever since about a year ago, and that's without jumping through any special hoops, asking special permission from anyone. We were able to do that. We are currently working on multiple revenue streams. So part of what we do is manage those different applications the vehicle can be doing anytime, whether that's in the middle of the night, whether that's early in the morning, whether that's in the middle of the day. And again, we provide you the information usually a day or two or even 3 days ahead of time, so you can use that to figure out what you want to do. Next slide, please. And then you can keep one more. So real quick, this is, besides frequency regulation, which you can do basically 24/7, 365, you can do it anytime, but it doesn't quite make as much money per hour as some other revenue applications. This one is demand charge management. So this is another revenue application we're going to probably start doing this week or next week in Danville. And with this one, I just want to walk through a basic, this would be a typical month where this is a project we're looking at in the Mid-Atlantic region. It's not in New York City or Massachusetts. It's actually in a mid-sized town, a regular town in Virginia, where you've got basically 3 events that happen in the month. And this happens to be, we're looking at November here, and those gray spikes that you're looking at are the facility load for a public building. And the gray is the energy and the power that building is using, and you see these spikes. And there's 3 spikes that happen that are particularly large. And what we want to do is the first one, you would get a notice, 24 hours ahead that, hey, it looks like, from noon to 1 tomorrow, if that vehicle is parked, I think in this case you'd make about $50 an hour. You can choose if you want to do that or not, but that vehicle will be worth $50 an hour tomorrow at lunchtime. So this car would then be parked. Next slide, please. From about, let's see, noon to about 1:30. And for that, you would save on your electricity bill about $50. Next slide, please. So this is a couple weeks later. We have a different type of peak where in the morning, I think in this case, you probably had a very cold night, and then at 8 a.m. to I think 11 a.m., this would be a slightly longer discharge when that building wants to warm up in the morning. If you happen to leave the car parked there, and maybe all you need in this case is just one car. It doesn't matter, any EV will do. You leave it parked there for in the morning, you'll make, again, about $50 an hour for 4.5 hours, and then the next day, another cold morning, you're going to do basically the same thing. So, and all in total in a month, on average, to do just this particular demand charge management application, usually 1, 2, 3 events, maybe two mornings and an afternoon. That's typically what we try to target. Any more than that, it's using the car too much and becomes potentially problematic with your logistics schedule. But again, every fleet is different. Every site is different. So in this particular month, this site would earn between $400 and $500 by these events. And in a year, that's about almost $4,000 or $5,000 a year. Over the 10-year life of the charger, that's $50,000. So that you've paid for the charger probably in year 3 or 4, Then after that, you actually start paying off the car. By the end of it, you're probably paying for at least half that car, if not more. In this case, it's just in Virginia. If you go to other places like Southern California, parts of Massachusetts, and other regions of the grid with much higher demand charges, it can get twice as high as this. You can obviously make a lot more. And that's, I think that's all we have. On the last two slides, this is just an overview of our project process. What we're doing now is this initial survey and evaluation. And the last slide is a basic initial survey of, it's not unlike if you've ever done a solar survey where they ask you for your electricity bills and perform a basic load analysis, where that interval load data is usually available from the utility, where it is in Virginia and I think California and those places. And that's basically how it gets started now. And I think that's it from us.